Around the world, there are about 7 major tectonic plates and a number of minor ones. And where these tectonic plates meet one another, we call them plate margins. And depending on which book you read, there are 3 to 4 different types of plate margin. And in today's video, we are going to be looking at these 4 types of plate margin: constructive, destructive, conservative, and collision. And a constructive plate margin, 2 tectonic plates move away from one another. They diverge in opposite directions. For example, at the Mid-Atlantic Ridge, the North American plate and the Eurasian plate are moving in opposite directions away from one another. And as these plates move away from one another, magma from the mantle rises up into the gap between them, constructing or forming new ocean floor. Hence the name, a constructive plate boundary. And as magma pushes its way up through the margin, earthquakes can be caused. On top of that, we also have the formation of shield volcanoes at a constructive plate margin, which tend to be very broad and very pudgy, very gently sloping. And at a destructive plate boundary, 2 tectonic plates approach one another. An example of this type of plate margin can be found just off the coast of Japan. A deep trench has formed as a result of a destructive plate margin called the Japan Trench. At a destructive plate margin, a continental plate and an oceanic plate collide with one another. As the continental plate is less dense and the oceanic plate is more dense, the oceanic plate sinks beneath the continental plate, kind of like that. We call this process subduction. This melting, subducting plate creates magma, and this magma is much less fluid than the type found at a constructive plate margin. And so as a result of that, when the magma pushes through and an eruption takes place, it forms a much steeper, much taller type of volcano called a composite volcano. And these volcanoes tend to have very powerful and very destructive eruptions. It's almost as if I'm trying to make this a little bit easier for you guys. Also, at a destructive plate margin, we can find powerful and destructive earthquakes. Who would have guessed? The reason for that is because of high amounts of friction caused by the subduction of one of the tectonic plates. So a nice little easy way to remember it: at a destructive plate margin, you have powerful and destructive volcanic eruptions and powerful and destructive earthquakes. Bob's your uncle, I guess. Thirdly, as a conservative plate margin, 2 tectonic plates either move away from each other in opposite directions, sliding past each other like little slivery snakes, or they move in the same direction, I don't know how to do this with my hands, at different speeds. A really good example of a conservative plate margin would be the San Andreas fault line in California, USA, where the slower North American plate is sliding in the same direction as the much faster Pacific plate. At a conservative plate margin, there's no volcanoes, there's no magma present or anywhere for it to get through or be created. So there are just powerful earthquakes at a conservative plate margin. Now, on to the last type of plate margin, a collision plate margin. Before we start explaining it, I do have to talk a little bit about textbooks and teachers. Depending on who you ask or what you read, this plate margin may come under a different name or may not be present in the book or lesson you are receiving. Very simply, some people do not consider this to be its own type of plate margin. Some will simply say that this is another type of destructive plate margin. Personally, I like to teach a collision plate margin as its own separate thing because no subduction occurs. So in essence, it's very different from a destructive plate margin. However, some teachers and some books rope it in as a type of destructive plate margin, hence why, depending on where you go or who you ask, it might be called something different. So it has many different names. It might be called a destructive collision plate margin. It might be called a collision zone. It might literally just be a destructive plate margin, but with 2 continental plates instead. It doesn't really matter, as long as you at home are aware that a destructive collision plate margin and a collision margin, whatever it is, it's the same thing. It's all this type of 4th plate margin. I just prefer to teach them as 4 separate things. Waffling over. Let's get into it. At a collision plate margin, 2 equal density tectonic plates meet, so it could either be 2 oceanic or 2 continental. As they are both of the exact same density, Rather than one subducting beneath the other, they both collide with one another and they cause the crust of the Earth to buckle and begin to uplift, so they start rising upwards. This process of crumpling and folding and uprising forms chains of what we call fold mountains, which are basically mountains formed from the crumpling of the Earth. A really good example of a collision plate margin is found at the Himalayas, which is where the Eurasian plate and the Indian plate collide with one another, and they push upwards, creating a chain of fold mountains, aka the Himalayas. Fun fact about the Himalayas: as it's formed through the process of fold mountains, what that means is two tectonic plates push against each other, the fold mountains form, and they grow each year, which means that Mount Everest, the tallest technically mountain on Earth, grows each year, grows by roughly 2 centimeters each year, which means if you want to nab yourself a really easy world, I say really easy world record, not easy world record, whoever most recently has climbed Mount Everest has technically climbed to the new tallest point on Earth. So you're welcome, go nab yourself that world record if you really want. I think I should do that. I should go nab that world record. That'd be very impressive. I could just add it onto my green screen in the back of every video. We're not doing that, are we? At a collision plate margin, there are no volcanoes because there's no magma once again. It's just mountains, no volcanoes at this one. However, there are very powerful earthquakes because there's a lot of friction that can happen, and friction equals earthquakes. We'll find that out in our earthquakes video in the next few weeks. And so that's it. That's the 4 types of plate margin: constructive, destructive, conservative, and collision. Lovely. And so that's all for today. As always, there will be a worksheet down in the description below. And with that, it's time for you guys to pack up, like the video, subscribe to the channel, go follow me on TikTok, and I will see you in the next one. Adios. And as the magma pushes its way up through the margin, earthquakes can be caused. As long as... I got it wrong. And at a an example of this type of plate margin can be found just off the coast of Japan. No, I'm mixing them up. I'm waffling. I'm really getting it all wrong today. Oh, it's a Sunday and I really don't have the energy. Woo! Right, that was the opposite of not having enough energy. That was too much energy. And as the magma pushes its way up through the crust, this can usually cause things like earthquakes and, nope, waffle. At a destructive plate margin, a continental plate. This video has broken me emotionally, physically, and spiritually. I don't think I can carry on talking about plate margins. Right. I'm broken. I am broken. At a destructive plate margin, a continental plate and an oceanic plate collide with one another. As the oceanic plate is more dense, it's heavier, it subducts, which means it goes underneath the continental plate. So kind of like that. This process is called subduction. It's just when one heavier plate sinks. No, I'm waffling. Waffling. I just know I'm going to have to edit this video back, and just watching me on the verge of tears about tectonic plate margins is either going to be incredibly funny or quite sad. So I look forward to that one.